Welcome to Check on Learning, section 2.2. I think. I am a Jedi Knight. Let's get started. So here we are. What? Yeah, so this is Check on Learning of whatever, 2. Yeah, I did get it right. 2.2. I'm sorry, Luke got it right. So it says, what properties apply to addition with complex numbers? These first couple of questions I think are just conceptual stuff. So the associative property, the commutative property, and the distributive property are all things that we use during addition and actually subtraction as well. And of course my face is in the way. Oh, I like to double check my answers just to make sure. Commutative, associative. The identity property of 0. The identity property of 0. Nope, I don't know where they're getting that from. So I will say the distributive property is only if you have something like, I was thinking if you had like 5 plus I plus something, you distribute that out. But that is not what they are talking about. The identity property of 0? I don't know about that one. I wouldn't worry about that one either. Like that's not going to be a big deal. What properties apply to multiplication with complex numbers? So definitely associative, definitely commutative. This time I'm pretty confident about distributive. I don't know, identity property of 0, maybe, maybe not. Let's see what they said. Oh no, the identity property of 1. Great. Did I miss the distributive? No, okay, yeah. Distributive property. Again, this is the identity properties of 1 and 0. That is not a thing that I'm going to ask you on a test. That is probably not a thing that you would see on the ACT, and that is just not a thing that I think you really need to know. But whatever, it's in the book. So if you really need to get your green check marks, that was the answer. Identify the real and imaginary parts of the complex number of negative 12i. So the imaginary part is negative 12. What's the real part? There is no real part. So because it's addition, though, to get rid of that real part, we would say it is 0. Hey, look, I started getting the right answers again. Whew. Okay, here we go. Now let's actually do some stuff. So we've got negative 4 minus 9i plus 15 minus 3i. I think the associative property or whatever, one of them says that we can drop those parentheses. And then we've got something like this. We will combine our like terms. And then we're going to have 11 minus 12i. 11 minus 12i. So there you go. Perform the operation. This is a multiplication this time, so don't forget we're using the distributive property. So we need to make sure that we do that. So we're going to take 5 times negative 2, 5 times negative 10, negative 6 times negative 2, negative 6 times 10. So here we go. So 5 times negative 2, 5 times negative 10. So that's going to be negative 10, 5 times negative 2, 5 times negative 10, I, be negative 50 I. And then we're going to take negative 6i, and right there. So then that's going to be negative 6 times negative 2 is a positive 12i, and then negative 6 times negative 10i is a positive 60i squared. So now we're going to combine like terms. Remember, this is going to turn into a negative 1, and we're going to have a negative 38i, and then a negative 70. Just to double check. There you go. So we did multiplication. Now we're going to do division. So we've got 4 divided by 1 plus I. That to me seems kind of a little, I won't say tricky, but almost seems like it's too easy. But if we rewrite it as 4 over 1 plus I, you'll hopefully very quickly see that there's an issue here. We've got an imaginary number in the denominator. So we don't like that, so we're going to multiply by a fancy version of 1, and hopefully you should know that this is the conjugate of the denominator. So we're going to multiply by, again, fancy version of 1. Oh no, where'd my stuff go? I plus, there we go. And the conjugate of 1 plus I is going to be 1 minus I. So 1 minus I on both sides. And so now we've got our problem. So we're just going to multiply all the way across. So if I take this 4 into the 1 minus I, I'm going to have 4 minus 4I. In the bottom here, we'll have 1 times 1 is 1. 1 times negative I is negative I. I times 1 is positive I. I times negative I is negative I squared. So these guys cancel out. And then we have 1 minus a negative 1, because remember I squared is negative 1. So minus minus sign, so we're going to have 1 plus 1. So we're going to have 4, and I'm just going to pull that 4 right back out because we're going to need to simplify some stuff, over 2. So we've got 1 minus a negative 2. Negative times negative equals positive. So now we've got 2, 1 minus I, and then we can put that, so our 2's cancel out right there. That turns into 2. So then we can put that 2 back in. So now we've got 2 minus 2I. And that is the answer they are looking for. 2 minus 2I. Okay, last but not least. A circuit shows that the impedance of a component is negative 56I. Is the component a resistor, a capacitor, or an inductor? That's cool because you totally have that chart memorized, right? So I'm looking at it off screen. Remember, a resistor is a real number, an inductor is a positive imaginary number, and a capacitor is a negative imaginary number. So which one we got? So hopefully you're looking at it and you see that it is a negative number. So therefore it would be a capacitor. That is not a thing that you have to have memorized for this class. Again, I'm more interested in you being able to work with the equations and make sense of them as opposed to memorizing stuff. So there you go. Hopefully this makes sense. If not, bring your questions in class and I'll see you there.